later distribute the recording. Okay, hello again to whoever will listen to the recording. And today I'm going to show you I think a little side project of mine for some time now, which is the generation of Gdml files with the Kotlin and using VisionForge framework to visualize them. First of all, I do not think I need to go into details about what Gdml is, because people who know what it is, they know, and people who do not know, I think they should look it up. And now, let's see the whole screen. Okay. Let's go to the project called Gdml. It's located on the GitHub. Probably should switch to presentation mode. It's located in the GitHub, and we can find it in our laboratory GitHub. It is here. Here it is. It's called Gdml kit for Kotlin bindings. And now let me show you what is inside. So first of all, what is the problem with the Gdml? Gdml is an XML format. You probably know about it, and it is used. It is one of the most robust ways to define the geometry in Giant and root, and it's used quite broadly in simulations, in particle physics simulations, and particle physics experiments. So why do we need a generator for Gdml? The problem is that Gdml, I probably have some kind of example here. For example, here it is. Yes, it's a baby Ajax. So we're talking about Ajax today. So here is it's probably old version of D0 detector for baby Ajaxo, and a lot of XML code here, and even there is a so-called XML programming where you use not values but expressions, which is sometimes hard to do properly, and a lot of repetition. So you generate like 1,000 lines of code, and it's quite hard to do it by hand. And the Gdml was designed to be human writable and machine readable. It is XML after all, and it's not the worst kind of markup languages, but still it's very hard to do it properly. For example, let's see. So in order to properly write it, to spend not so much time writing it, one can design a so-called DSL. It's called a DSL domain specific language. I do not like the abbreviation when it is applied to Kotlin, because I like to call it type-safe builders, but people call it DSL anyway. So what we want is for it to be like this: a simple code in the universal language, which allows us to easily create structures and have cycles and have tools to produce for people to easily read it and easily write it. And you also want to do computations inside, of course, or maybe even complex computations. And that is why I've created the format. And you can see here is the file called cubes. And just for the reference, here is the Gdml file generated. So you see, it's still not that large, but it's like 250 lines of code with a lot of repetition. Okay, how it works inside. How it works inside. In order to do it in a type-safe way with the help of IDE and other tools, we need to create a structure for the Gdml. For that, I took a reference. I do not have the Gdml reference here, but I took it and just read it and implemented Gdml nodes. For that, we have a top-level node called Gdml, and it has number of containers. It's have a defined container, which stores the information about values and variables. And yes, Gdml has variables. Material container, which is so important for our friends in Ajaxo. Solids container and structure container. For those of you who do not know, Gdml defines separately simple solids and constructs created from those solids. So you have two different containers. In this case, it's a little bit more complicated because Gdml specification allows to define multiple containers of the same time. So you need not only to create one container of each type, but also create multiple to allow creating multiple definitions of those containers. Here you have some utility functions which allows to access the first. This class is used both for reading and writing of this Gdml, and so when I read it, I just can access those containers and read all the contents. And when I'm writing it, I probably do not want to have multiple containers. So for that, I have those for reference: define, material, solids, and structure. And then inside those types, for example, in Gdml define container, I have functions to define Gdml items. For example, I can define the position, which is has type Gdml position, and they can define rotation and nothing else. So there is also probably matrices here, but they are not moved to this level. You can always use a manual registration of the component. So you just call this register function, which is, I will just fall inside. The register function just uses it's wrong here actually. It's not solid. It's item. So you define the type which corresponds to the type of the container, and it returns, which is very important, it returns the reference. Because in Gdml, you can probably see it again in this source, all volumes and solids are used by a text string reference. Because you need a way to represent a reference in the text format. So when you are working with something, you work with a reference to this object. So here it is. And you have a position and rotation for defines. For materials, all basic functions. Maybe I missed something, but it is quite easy to add something new. And for solids, it's the most bulky part. You can define different solids like a box, sphere, orb, ellipsoid, elliptic tube, elliptic cone, etc., etc., etc. And finally, even some Boolean solids, where one solid is a combination of two different solids, is a union, intersection, and subtraction. And for structure, you can define volumes, assemblies, and I think there is a division volume, but I'm not sure. I think it's not implemented here in the builder. We can add it later if we need. And for the setup, we also have some metadata like the name of Gdml and the version of Gdml, which are also come from the Gdml specification. And we have a reference to the root volume. Everything is more or less clear right now. I think if not, please ask your questions. So now let's go to actual solid definition. Some sample solid here, like box. Everyone likes boxes. So here, what I do, I create the box object with a given name, numbers. Then I do the Kotlin trick. I apply this function. This notation means that the block is the function applied to the type Gdml box. It's a lambda function. And I modify its values, and then I register the resulting box here. And I return the reference to this box. Let's see how it works inside. So the Gdml box is a simple thing. It inherits a solid. The solid has only two fields. It's units. Oh, they are also type safe here. I'm not sure that Gdml, the Giant, has a strict specification for units. In this case, the units are strict. You can use only units from this list. It could be easily updated. But I'm not sure. Maybe in future we need to add more. And that's all. You can read this Gdml box. Those are variables. It means that you can read it as a number and then write it as a number. And there are mandatory fields like these ones. And there are optional fields, which are, when you read them, the defaults are used for them. And the same goes for all other elements. Yeah. This is a part of Gdml XML schema. Here I used it to create those things. The only thing that one needs to be to know about is that the distinction between the reference and the object itself. For example, in the scale it's solid. I'm not sure anyone uses it, but in this case, it uses the reference for the solid itself, but actual scale for the scale parameter. It means that in the XML, you will have a reference here, but actual scale definition here. But the same goes for things like, I'm not sure, for example, like unions. What here it is. It's a Boolean solid. It has a lot of different things, and you see here you have, for example, two different accessors. One for actual position defined inside the Boolean solid, and another one used for the reference. So two different types of objects. You can use one in the place of another one. And that's mostly all. Also, there are some nice helpers here. For example, if you want to define the extruded object, you do not need to define it in the XML way. You just use extrude. Well, we can probably do that right now. Let us do this. Just create a new test. 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 And then we the Gdml is a function which it's a little bit more complicated here. Anyway, the Gdml is a function which accepts a lambda function as a parameter. So all it does is create a new object that applies this lambda to the parameter. And here, for example, we can do it like this, and I have to use this extrude function takes two arguments: the name of the solid and the block which defines it. In this case, this block is mandatory. because it's a second parameter. Otherwise, it says that no parameter for the block, and I have to use it. In case, for example, of box, I do not have to. I can use additional parameter, for example, like this one, but it's not mandatory. It's optional. So now extrusion. Now, if I want to understand how it works, all I need is to this and see the functions which I have in this object. For example, I want to add vertices here, like, for example, 10. It's a two-dimensional vertices. It requires, in this case, for some reason, it requires double and not number, and we can check for we can simplify it later. Vertex. And the final one. Plus minus. Then we can define sections. The section, each section must be indexed, and it should contain the Z position. Section. And I think there are some other. We can also use lambda function here for Z scaling factor, for example. This one will be a prism, cut prism or something like that. So now we can print it and see what the Gdml is generated. And run test. Sometimes I need some time to load dependencies because it's the first time I run it on my computer. So it takes some time to prepare it for the first run. Okay. Here it is. And here is the generated Gdml. Something like that. I'm not sure it's correct, but I think it is. We need to check the specification. And you see all other sections are generated as well as default setup section. Okay. This is it for the Gdml itself. Everything else is done the same way. There are a lot of tweaks could be done to the DSL, to the user experience here, and please leave issues if you have some ideas. But all in all, it's a pretty simple thing. For example, as I already showed you, for example, this is a cubes with a deep cycles, three-level cycles inside. It works. Actually, when I was doing this Gdml at first, I was doing it for reading Gdml, not for writing. So now we can use it for writing as well. What is important here is this is a multi-platform project. So it means that we have this code run on JVM, then we have this code running in GS, I mean in browser, and it works. And actually, you can move all your tools to browser and just load the specific page, and it will work. It is also possible to provide native bindings, but it's a little bit more complicated because the library I use, which is the library I used for XML parsing, which is called XML util, somewhere here, somewhere here, somewhere here. No, it's the wrong one. And where it is. Oh, well, it doesn't really matter. So I use, I think it's inside here. I use XML util library, and it does not have native bindings. So it is possible to do everything here on native as well if we had a native XML parser. Otherwise, it works fine. Also, as we were discussing with Louis right now before the meeting, is it possible to do the same in command line? Yes, it is. And I've actually done it in like 20 minutes I had. Here's this new module, Gdml script. And probably just, I will just build it and show you how it works. So I built the application distribution, install distribution. It will take some, it is installed. Now I am going to, sorry, it's smallish. Now I'm going to this, well, probably I can do it the same from the idea. I can just launch the terminal here, okay. Will be better. So now I'm going to the Gdml script and to build Windows terminal. And I am it's easier to use. Yes, here it is. Okay, now I want to run a script which I also prepared. It is here in test files. It looks like this. It's just the same cubes script without Gdml frame. So it's just inside of the script. And it should work with a code highlighting idea, but since I did not have time to test it, there could be some problems. And what I do is that I take the path to the script a little. I just copy it, and then I go back to the console, and oops. Yes, I know. Script, and I just paste the path to the script. Oops. Yes. It's wrong directory here. I need to go to the bin directory. Yes, now I'm in the bin directory, which has a Linux start script and Windows start script here. And I use start script and write the name of the file. There's some warnings here, and here it is. I have just transformed the file from this script representation to the XML representation via console. I can also use a output file name here. I can provide input and output, but I just put it to the system out instead. Okay. For some reason, it's cut in the middle. Okay, I will fix it in the future. Now, I think that's all for the Gdml itself. So if you have any questions for this part, I can answer them right now.
Well, I have some questions. If you could do some specific examples, because I tried to do some things and I could not do them. So perhaps you can show me.
Okay. You asked me about the subtraction. Yes, because I did the actual subtraction. I changed since the subtraction worked before in the version you have, but right now I changed the DSL a bit. But basically here how it works. You use this Gdml. Oops, now let me close it. You define one solid and then another solid, and then you just create a subtraction in this way. So you have two references here, because the subtraction function takes a reference and a configuration block. So in order to combine, to subtract two figures, I need to tell the first one and then the second one, and then offset position. If I want to experiment with the other things, I can just check what options do I have. I check this, and I see a lot of functions here, like first position ref, first rotation. So I can set both positions, rotations, and reference to positions and rotations here. For example,
Okay, now thanks.
Yeah, for example, we can add a rotation here, like val rotation define rotation, and here, like, I'm not know, pi over 2. Why doesn't it work? It should.
Yes, this is what I was having trouble with doing it this way.
Yes. The problem is that you see here the first argument is a name, and it is mandatory in this case. So if you want to define a rotation, you need to put a name to it, like rot, and then it will work. For defining Gdml, or you can. For the position itself, it's not mandatory. You see here I work without name, and actually this will work in the version you have right now. But since today I changed it a bit, for example, I moved the name from the first argument. So now I define all arguments are optional, but it depends on the order. So if you want to use a positional argument, they need to be placed in the correct order. Right now, I can remove those because I will already have them in the correct order. But before this change, the latest version, it's a 0.3.3, I had to place empty name here, like this, in order to work with the positional arguments. But this one will work anyway. And for defines, you have to provide a name, because otherwise you can't reference it.
All right, I just tried it and it worked. Thanks.
Yes. So this how it works. Of course, as I already said, there are a lot of things that could be improved, because I never intended this DSL to actually build complicated Gdmls. At first, I used it to read things, not write them. And now a lot of improvements could be done here without breaking. And
right. I wanted to ask you another thing regarding the name field, which is mandatory right now. So, for example, if I want to make a chain of unions, I would have to create lots of names that don't have any use. They are just used on this subtraction or union. So perhaps this could be made optional, or there is any other workaround.
Actually, I think it is possible right now. Let us see the specification. I mean the Gdml, where it is. I mean the specification for the Boolean. Yeah, you see the Gdml expects a reference here. So I can't place an object here directly. At least if I read the specification correctly, we need to recheck that. The problem is that the Gdml has a specification. It has a schema, XML schema, but I am not sure that Giant follows the schema properly. So there could be things that are not allowed by the schema, but are allowed in Giant, for example. You see. So I use the schema. If you have some things that are not so standard, we can add them as well. But I'm not sure it will be possible, because here we see that the first should be a reference. I'm not sure.
Okay. Like in the past, when I tried to do this, I used to recycle the same name over and over again. So if I wanted to make some solid, for example, the initial solid was named box, and then I would do some subtractions and unions, and I would keep naming it the same until I arrived to this final volume. I don't know this, but I think I stopped doing it this way because it generated some. It was hard to debug, and there were some issues. But
I really do not like this idea, because it will provide a lot of errors can come from this. But as we are working with a full-scale, full-fledged language, we can do the simple thing. For example, we can do it like this. We can do a function, generate a random name, and we can let me generate next name and create a counter here. And set it to 0. And let this function return temporary name counter. And then you can replace your names here with this function, and it still will work. And if we generate it right now, you will see that the name, here it is. The name will be unique, but it will be generated by the machine. Right. And it's quite easy. So if you want, we can add the make this name here optional and automatically generate name when you do not need to use it, if you want.
Yeah, I think it would be useful, perhaps generating the name from the class name, the object name. I don't know how hard that could be, but
yes, it's quite easy. Yes, please.
Yes, I'm doing lots of copy paste, and I think it could be improved in that way. Yeah.
Okay. Just put the issue. It will break the backward compatibility, because if this name is not mandatory, it will be moved here. Will move it position here, but it will work. The name will become optional. So it still will work, and it will provide unique identifiers. Just put the issue on the GitHub, and I will implement it in like 5 minutes. Okay. I think that's all for Gdml, and it could be, I showed you, it could be used as, I use it for parsing Gdml actually, and I use it also, we can use it also to generate, and it could be easily improved. The usability could be easily improved. And we had a plan to actually use it to make remote calls to Giant. So, for example, if you want to generate some kind of geometry and then run the simulation and get the result, and you do not want to work directly with the Giant, you can just run the Giant as a server, which accepts the Gdml and returns the result. Of course, there are a lot of problems with that, not the principal problem, but details, technical details about, for example, interruption and errors and etc. etc. But I think the Mikhail Zeleny did a working prototype for that. Okay, now we are going very briefly, because it is quite technical, we are going over the VisionForge project. And the VisionForge project is quite large, and also let me show you it on the GitHub. It's a long one. It's here. It's a large project. It was created to actually for physics, for visualization of events in the physical experiments. And now it is much larger, because it supports not only the 3D visualization, but plots with a plotly kit, and it is supports plugins. So it is quite easy to add plugins here and render text, articles, knowledge bases, etc., etc. And everything could be easily added. Here you see the demonstration for the muon monitor in Confront. We were doing analysis for that and some primitives here. And let me say what is important here as briefly as I can. So you see the project is huge. A lot of modules here, and there is a core module, and here you see the Gdml converter, the Gdml converter based on this Gdml library. And what it does, it converts the Gdml representation, I mean this type-safe structure, into our inner JSON-based representation, which is used for visualization, because Gdml is terrible for actual visualization. The structure is not nice, and it's hard to use it directly. So we use our own inner representation, which took maybe the best part from the Gdml, and but still is much more flexible. And then we render it, and then we transform with here. The classes here are actual transformer. It transforms the Gdml structures like boxes, bool solids, etc., to our inner structures. Not all Gdml primitives are supported here right now, so it is quite easy to add those. You just need to create an appropriate mesh generator. It's not hard. For example, we can probably see how it is done in sphere. Spherical layer here and spherical layer, and here it is, the mesh generator. I mean, you just generate how it looks like. It's not that hard. But since I did not have a lot of time, where am I? Some not frequently used primitives are not here yet. They need to be added. I mean, the rendering for them. Also, I think there are still some bugs with the visualization that need to be fixed, mostly minor ones. And I said, we transform this to representation, and then we go to a more complex thing because the visualization is done in browser. This Gdml and whatever we do is on the server side. And the visualization is made on the browser. So for that to work, you need to create the so-called full stack application with a backend side and front-end side. And for example, we can see this Muon Monitor project. It has a common code which has the model for Muonic events. Like in this case, it's very simple because it just has a number, ID, the track, which is a line, or not line. In this case, it's could be some multi-line thing. And then we need a collection of hits, meaning which detectors are hit by the muon. Then we'll have a simulation, and they have a geometry definition for this muon monitor, which is also done in multi-platform code. I mean, this Kotlin common. And here it is. It says individual detector. It is a block of 16 individual scintillation pixels. And this monitor is uses the similar DSL to define those detectors inside. What is important, by the way, is that you can create functions. You do not have to use standard primitives. For example, if you have a similar blocks both in Gdml and here, you can use functions to abstract away your logic. And for this muon monitor, we also have a front-end part, which is in this case done in React.js, Kotlin wrapper for React.js, and maybe I'll leave this one. And you see here some things from the web design. I mean, the CSS and JavaScript, and we use it to show how it looks like. And it gets, since the platform is modular, so for example, if you want to do a Gdml visualization, you need to load this 3D geometry from module called solid. On the backend, you need to also load it on the front end, so you have the same structures, and you also need to load the Free.js renderer on the front end. And Free.js is a JavaScript library which is used for the visualization right now. And it's get a little bit complicated, but we can now simplify it greatly. For example, let me show you how maybe it's I will just show you the beautiful picture and then explain how it works. Let us go to the Jupyter, and here this is a file. You have access to it. It's in the same directory I've created here earlier. It's called Gdml. IPython notebook, and we have several declarations here. Probably I should increase the font. First of all, I put the repository. I do not set up any environments here. We discussed with Roland today about environments, Anaconda, and other things. I do not set any environments here because I do not need to. All I do, first of all, of course, I need to install the Kotlin kernel for Jupyter. And in this case, I need to install the development version. It's in the GitHub. It's easy to find. And I need to install development version because we use some of fix we've done with Ilya here, in the last days. So we need a development version, and I've installed it. And then we put a link to the repository. It's our repository in the JetBrains space. Also, we need to additional repository for Gdml parsing library provided by Paul DeRisa. And then all I need to do is put the dependency on my artifact itself. It's a space, key science, it's a group, VisionForge, Gdml, Jupyter, GVM is the name. GVM is a prefix because we are using a GVM version for the kernel. It's on the backend. And this is a version, you see, it's pretty development version. So that's all. I just hit it. It will take some time because it needs to load all the dependencies. If you hit it the first time, you need time to download those dependencies and actually embed some JavaScript in your file. And then I create the same cube here. You see here, it's old syntax because it's use Gdml 3.2 or 3.2. It still requires those brackets. I do not think it will work without them. No, it won't work. So in the version 0.3.3, it works without these annoying things. And then I just, like in Jupyter, I just say the display me the object, and here it is. I probably should make it smaller. Here we have this nice rendering, and we can change how it looks like. And that's also the thing I've added today. I think it was today. I've also added the control panel I use for Gdml demo. So now I can see the tree of my objects. There are some bugs here. For example, this bullet should not be here, but I will fix it in future. It's like some kind of CSS thing. But I can see and select. You see, this one is selected. And I can see select different parts, and I can select it by mouse, clicking the mouse. And what is more important, I can change the appearance. For example, for example, this box I do not like. So I go to properties and say, let it be invisible. So it's invisible now. And this one, I want to be only wireframe. Okay, there it is. And this one, I want to be red. Well, okay, violet or something like that. Here it is. And I can navigate here and make it invisible too. And I can reset the colors and properties to the base thing. There are also a lot of features here, like styling, because those components, they include styles, and you can see that this component, it's a box here. It has some styles inherent from the Gdml. So you see this property Gdml material. It does not do anything. It just points that during visualization, we can use some properties which are from the Gdml. We do not use it anyway. And for example, we can change, at least in programmatic model, we can change styles here, like those volumes are opaque. I forgot how to pronounce it, opaque. And we include edges here. You see this black lines. A lot of things to do, of course. This, and we can even we can have layers. Currently, there is only one layer here, but there could be an axis, turn on axis, and we can export this to a JSON file. And you see JSON here. And here, how is JSON works. Actually, Luis, you asked me if one could use our rendering engine without Kotlin backend, yes, one can. For that, you only need the JavaScript file, the compiled JavaScript file, and you need to pass this JSON to this file, and it will work. We need to standardize and stabilize the format, but I think it won't change greatly.
Okay. Do you mind doing showing me this, because I tried to do it this morning and I could not do it. It didn't display anything. It didn't give any errors, but it was just white. I don't know. I just pasted the JavaScript, everything between the script tags into an index.html, and
yes, I think that you should write what exactly do you need, because there are a lot of different scenarios here. Sorry, where am I? A lot of different scenarios here, and you can create a standalone versions. I will do it right now, I think, later, and we can see how it works. Now, the thing that was not working last time we talked is the actual export to XML, because there was a bug in the Jupyter environment, and we fixed it just yesterday evening. And now you can export it. For that, you just need to call this line. And here is your Gdml. And you can also export it directly to the file, like with this. You need to some additional imports here, but it should work. Oops, where it is? Here it is. And you can see that the file is there. It's generated. So you can export it directly to the file. We can also add some kind of buttons or widgets to make it more convenient. Oops. There's a question?
I don't want to interrupt. So before we move on, because I like very much the idea that you can customize the visualization, changing colors and so on. And is there a way to associate visual properties to materials, for example?
Yes. We can go back here. We can go back here, and we are going to this converter, transformer here. It's still experimental here, but oops, it's the wrong one. No, I wanted to transformer. It still is pretty experimental here, because I was experimenting with a different user experience. And see here, I've added the function paint, which takes the material, the Gdml material as an argument, and colors material in any way. I think I use it somewhere. Okay. We can even try to use it right now, because it should be available in the Jupyter as well. Let me go back and show you. Here I've exported the cubes, and now I'm using the Gdml from Baby Ajaxo, the old zero geometry. I have not updated it. There was a challenge with this, because this Gdml file, it is here. Here it is. It actually uses expressions. It uses expressions. So in order to convert those expressions to my nice type-safe model, I need to create a preprocessor which will evaluate those expressions and compute, and it will go from upside down and evaluate those expressions and compute the numbers here. And it is not so complicated task, but it requires some thought. And we've used a pretty nice library called Better Parse. Let me show you. Better Parse. Yes, it's done in the free time by one of JetBrains employees, and it allows to create a combinator parser. And there are also some contributions from our group member Yaroslav here. So I used it. For now, it works on the GVM. I think there is a pull request that from Yaroslav, which allows to use the expression evaluation on the JavaScript side as well. But for now, it works only on the GVM, and it's okay for us right here, but because we are loading the Gdml file on the backend side. And for this to work, we need this preprocessor to be explicitly enabled, because it disabled by default, because I do not expect a lot of people in Gdml to use expressions. I'm not sure if I'm correct. By the way, did you know that you have some mistakes in your Gdml file? They are displayed as warnings here, but some names are not according to Gdml specifications.
Mm-hmm. Yeah, perhaps because it's too complicated to.
Yes. What I'm trying to say is that when you have a type-safe reader, you also can check for those problems as well.
Yes, that's why I like this so much.
Yeah, because I've actually checked those problems, and yes, there are mistakes. So there are fields that are not used by the Gdml. Okay, and now I want to display this, and here I had a minor problem. Let me comment it out and just display it as let me check if it is right. Yes. Let me show it. By the way, this notebook is completely standalone. It works without any Kotlin or whatever. It's just a standalone notebook that just needs the internet connection to download the dependencies itself. So you do not need to set up environment or whatever. It is not very small. It is like why it's so small? It should be like 3 megabytes after proper. Oops. It should be like 3 megabytes up after loading, but it includes the renderer, etc. So even if I reload the page, it will still display everything. So the problem you see here is that the sizes are wrong. The sizes of some elements are wrong. I showed you this earlier. We can now we can select those and see it's a pipe filling something. It's a pipe filling. Yes. Material vacuum. Okay. The problem was because you are relying on default units somewhere, and default units are not always the same. They are not specified in the Gdml specification. So for most of your primitives, you specified units explicitly, but for some you did not. And in order to make a thing work properly, I had to redefine the default unit. So the default one was centimeter, and I use a custom converter. So instead of just displaying the Gdml, I use explicit to vision conversion with the custom default value. And oops, what happened? And now it works properly. And there are no bad things here, and we can make what happens? Why doesn't it display it? I'm not sure why. Okay. We will remove this one, and this one we will make. By the way, I'm not sure about Gdml, but when we are doing visualization, it is much better to create more structured content. So here you have mostly flat hierarchy of things, but it makes sense to make them more composite to be
yes, that's another thing I wanted to talk about, because I didn't really know how to do this in Gdml. I don't know if it's possible.
Yes, I'm not sure it's well, it is possible when you create volumes that reference other volumes. So instead of doing a lot top-level volumes, you create a volume which contains other volumes. It's not very efficient in Gdml. I'm not sure it would work fine. Here I have some bug. For example, if yes, there it is. I will fix it later. Yeah, I had some kind of problem because it tries for Boolean solid. It tries to render its parts. Okay. This is bug, and I will fix it later. What I wanted to show you is you asked me about painting. It should work here. It should be paint. Yes. Paint function which uses it takes. It takes the material as a source, and then, for example, we can use something strange like a hash code. Oh, here it is. So you see, you can control the colors. Here I just use the automatically generated hash code for the material, but you can fully control the coloring here. And also, since the system is not fully user-friendly, we can customize this renderer for whatever your needs you have, and we can embed it in any application.
And would it be possible to make some volumes transparent within these two vision function, for example?
Yes. It actually also supported here because it also supported here. I can look it up later, but this option was done earlier for Bayesian geometry because it's too complicated. If you do not do some things transparent or even avoid to render them, it will be too large. You can customize it however you like here.
Right. And also, is it possible to increase the number of faces on the circles and so on?
It is more complicated. Yes, the actual geometry builder allows it. For example, we can open the notebook from earlier. And you see spheres here. And here is a parameter called detail. So you can set the number of spaces to whatever you want. By the way, here I think I have some kind of problems with my rendering engine because the quality is low. Usually the quality is much better. So yes, you can. But if you are using Gdml, you need also to implement this detail configuration on the stage of a conversion. It is quite easy to add those add a customization here. So we can add whatever you want. Just leave the issue, and we can add the customization, any customization you want to, and it will be done in the same way, like this. So you just, during the conversion, you just say how you want to convert this Gdml to actual visualization representation.
Okay. And if you go back to the maybe actual geometry, I think this thing on the exit of the pipe, I don't know if it's a visual bug or something, because I found when representing cylinders, sometimes they are not perfectly flat. They have like a spike on the, and this thing, this yellow thing on the right.
Yes. I'm not sure. I never checked. We can, oops. Yes. We can turn different things off and see. Oh, yes, spike. Of course, there is a problem here. You see a rendering problem here. It's probably caused by the composite solid geometry. The problem is that when you are rendering those intersections, when you create an intersection, in order to render it, you use the algorithm called composite solid geometry. And I currently use the algorithm used in the library, the FreeJS. Actually, it's not in FreeJS, but in another library on top of it. But it is quite possible that different rendering engines will implement this algorithm a little bit different. So this one needs to be discussed in the detail. I mean, this specific thing. If you think that this visualized in the wrong way, then we need to discuss it. For example, maybe it is makes sense to increase the number of polygons here to increase the detail, and maybe it will be better.
Yes, I mean, it's not just something from the maybe actual geometry. I did some test a few hours before where I just draw a flat a cylinder, a very thin cylinder, and it had some spikes too.
Yes, there could be different visual discrepancies between the giant rendering and this rendering, of course, and we need to look, just create tests and see if it is correct or not, and maybe improve some things. In the end, of course, doing such long, complicated geometries like BMN and the IAXO will require some kind of tweaking, like this one, to make it display correctly. And I'm not sure that Gian does it correctly. So here is just at least I know that the JS root, which is a JavaScript extension of root, and which also uses FreeJS, has the same glitches.
Yes, I've seen many glitches in this geometry too. Different ones, but I see some sections that are transparent and so on. And also when you have two very close volume boundaries, you don't see, you see a strange mixture of the two colors.
Yeah, that's okay. This is how 3JS rendering works, and usually the case is usually when indeed you have a very thin layers. Then one sometimes could be seen through the another one. It's not about the rendering. It's more about what you want to visualize. because those thin layers are meaningless from the point of view of visualization. But again, everything could be tweaked. So we can change materials here. For example, here we use very simple materials without reflection and without those edges. But we can add them to any object we want, and we can change the material reflectivity. We can add the light sources. So yes, we need to do it individually for each problem.
Yes, I think it would be nice to associate a texture, color, and so on to the material keyword, not just the material variable. Because, for example, I can use, if I have 3 distinct physical volumes, I can perhaps use the same material for all 3, but I can name it differently, because in the future perhaps I can.
Yes,
I want
that's
to change
you can do it right now. Here it's just you just create. You can do it easily. For that we use styling. And you see the styles. The colors are defined by styles. You probably will have to use a scroll bar here. And you see this is just a color in the web color representation. So we can have the same name and different color, or this different names in the same color, or we can add some nice things like I do not remember properly what other tools are there. Color. I just do not. I need to go to the code to see what other possibilities are there, because we have much more configuration to the color. Okay, I think I've shown you everything I wanted to show today. So if you have any other questions, please ask. If not, we can sit on it and make some improvements. And don't forget to write issues if you want something to be added.
Yeah, I'll write some issues. I have quite a few here.
Okay. Any other questions? No questions. Okay, then probably stop recording.